This is the 9.7 exit ticket where we're going to review describing bivariate categorical data. Number 1, determine what type of model, linear, exponential, or quadratic, would best fit the data if there is a relationship between the variables. I'm going to label these number 1, number 2, number 3, and number 4. What would best fit number 1? So this one, it does look like we're kind of going up and down again, and that would be like a quadratic, okay? That would be like a concave down quadratic. So that would be number 1. Number 2, this one is linear. Number 3, this one starts and then starts going up. So it's not a straight line, but this one you could say exponential. And then number 4, there is no association. All those points are random. All right, number 2, a survey was taken of 10 low and high temperatures in Fahrenheit in the month of April to try to establish a relationship between a day's low temperature and high temperature. Make a scatter plot of the data using your statistics calculator. Is there a positive or negative correlation between low temp and high temp from looking at the scatter plot? So if you're at home, you can use the online scatter plot calculator from the slideshow that we did today. So when you do graph this, okay, you should get a positive linear association. Okay, the scatter plot should be going up in a line. All right, B, the equation y equals 1.16x plus 19.07 was used to model the data. Interpret the slope and the y-intercept in the context of the problem. So the slope is 1.16. Okay, it's always the number next to the x. Okay, and that's your change in y over change in x. So this describes the change in your high versus low. Okay, so you can say that the slope means that you are increasing 1.16 degrees Fahrenheit in the high temp per 1 degree in low. So every time that goes up 1 in the low, it's going up 1.16 in the high. And then the y-intercept is 19.07, okay, and that's where x is 0. So if your low was equal to 0, it would mean that your high, you could expect it to be 19.07 degrees Fahrenheit. And C, use the equation y equals 1.16 plus 19.07 to predict the high temp when the low temp is 32 degrees Fahrenheit. Does our model overpredict or underpredict? So we are plugging in 32 for the low, which is your x. So we're going to have 1.16 times 32 plus 19.07. 1.16 times 32 is 37.12. And adding 19.07 to that, you should have gotten 56.19. Okay, so that would be our temperature. And if we look at the chart, okay, we do actually have that data point there. So this is an overestimate, it's an overprediction, because our actual data point was at 54 and we got 56.19. All right, how do you feel about this exit ticket? Do you have any additional questions?